press the bell icon on the YouTube app and never miss another update.
Hello students, today we discuss one more concept in the chapter permutation and combination. The last 3 classes we finish up fundamental principle of counting and factorial notation. These two are the basic concepts for the chapter permutation and combination. Now we starts the concept permutation. Very important concept. So today we discuss the concept permutations. So one definition I written, a permutation is an arrangement in a definite order. Arrangement of an elements. Simply, if anybody asks, permutation means what? Permutation is the thing but arrangement of an elements in a definite order. Arrangement of an elements in a definite order of a number of objects. It may be 2, 3, 4, 5. Taken sum. If object is 3, we have to arrange 2. If the object is 4, we have to arrange 3, like that, or all at a time. If the object is 3, we have to arrange 3 at a time. So you are not clearly understand. Yes, now. So I explain. So this is very simple definition. Permutation means arrangement of an object. So let I take 3 alphabets A, B and C. So in my pocket 3 alphabets are there. I have to arrange these 3 alphabets 2 at a time. Taken 2 at a time. Okay. So we have to arrange these 3 alphabets taken 2 at a time. So firstly I have to arrange A is the first place, B is the second place, A, B. In the arrangement, position is very important. A in the first place, B in the second place. One more I have to arrange by using these 2 letters only, BA. Here B is the first place, A is the second place. So in these 2 arrangements they are saying no, they are different. AB, BA. Okay, one such. Through with the A and C, AC, CA. So 3 alphabets in my pockets. So we have to arrange 2 at a time. 2 at a time. First I take AB. So BA is the first place, B is the second place, BA. B is the first place, A is the second place, AC, CA. Over? No. So B and C, BC, CB. Total number of arrangements is how much? It is 6. This we call it as permutation. Very simple concept. This we call it arrangement of an elements taken some at a time or all at a time. All at a time means what, sir? So I use these 3 alphabets A, B, C. Taken all at a time means we have to arrange 3 at a time. So for that how much we don't know. First A is the first place, A, B, C. A, B, C. One arrangement. Just I interchange these 2. Fixing A must be the first place. Fixing A must be the first place. A. B, C. I have to arrange C, B. Okay. A, C, B. So then A, B, C over B must be the first place. B must be the first place. B, C, A. B, C, A. C and A are interchanged. B, A, C. So A first, B first, C must be the first place. C, A, B, C, A, B, C, B, A. Any another type of arrangement? C. So total number of arrangement is 6. Here we taken all at a time. Here we taken all at a time. Here we taken two at a time. Here we taken all at a time. This is what the definition or else the concept of permutation. Permutation means arrangement of an elements. Permutation means arrangement of an elements in a definite order. In a definite order means 2 at a time, 3 at a time, 1 at a time, 4 at a time of number of objects. Here the number of object is 3 taken some at a time. So number of object 3 taken 2 at a time or taken all at a time. This we call it as what? Permutation. In the arrangement, position is very important. Here A is the first place, B is the second place. Here B is the first place, A is the second place. Overall simple concept. In a simple manner, if anybody asks what is permutation? What is permutation? Simply, permutation means arrangement of an elements or else arrangement of an objects according to the definite order. According to the definite order. Definite order means we have to 2 at a time, 3 at a time, all at a time. So one more, if you want, one more have to arrange. One more arrangement if you want. So if I take 3 alphabets, so if I take 3 numbers, 1, 2, 3, 4 numbers. 4 numbers in my pockets. I have to arrange 3 at a time or else 2 at a time. If I have to arrange 2 at a time, so we will see A must be the first place. Okay na? So number of arrangements means permutation. Number of arrangement 1, 2, 2, 1, 1 arrangement. 1, 3, 3, 1, 1, 4, 4, 1, 1 over 2, 2, 3, 3, 2, 2, 4, 4, 2, next 3, 4, 4, 3, or else 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total number of arrangements. Total number of arrangement is how much? It is 12. Okay, so very simple concept, very important. Permutation means what? Permutation means arrangement of an elements, arrangement of an objects according to the definite quantity. According to the definite quantity or definite order of a number of objects taken some or all at a time. Is it clear? So permutation concept clear? We will see the formula. So n number of objects in my pockets, n number of objects taken or at a time where r is greater than or equal to 0, less than or equal to n. This must be. That means what, sir? See, observe here. So just now I given one example, A, B, C. So how much elements are there? 3 elements are there in my pockets. So taken 2 at a time. So what are the possibility? Just now I written AB, BA, AC, CA, BC, CB. Total number is 6. So n number of objects. Here n is equal to what? 3. N is equal to what? Clearly observe. N number of objects taken or at a time. Here R is what? 2. Where R must be greater than or equal to 0 and less than or equal to n. This is very important. This value R must be greater than or equal to 0, less than or equal to n is denoted by, permutation is denoted by, very important. So n, p, r. This is the notation. This is the notation. This is the notation to denote the permutation. Permutations are denoted by, very important, permutations are denoted by NPR. This indicates what? N number of objects. We have to arrange. Permutation means arrangement. Arrangement for what? N number of objects taken or at a time. So observe here. Here it is what? 3 number of objects. 3 number of objects taken 2 at a time, 3p2. So the answer is what? Here we got the answer. 3p2 is equal to what? 6. 3p2 is what? 6. 3 number of objects. Okay, written here. 3 number of objects. We have to arrange 2 at a time. So the total answer is what? 6. 3p2. 3p2 is what? 6. So, n number of, what is the notation for permutation? Notation for permutation is NPR. NPR indicates n number of objects. We have to arranging n number of objects taken r at a time, where r is what? Greater than or equal to 0, less than or equal to n. So, here ABC, 3 objects taken 2 at a time, that we can denote it by 3p2. So how answer is 6. One more. So again 3 number of objects taken 3 at a time. So just now written A, B, C, correct? So the next B is I fix B, C, A, B, A, C. Next C, A, B, C, B, A. So total number of arrangement is how much? Total number of arrangement is 6. This can be denoted by 3 number of objects. Here R is what? 3. 3p3. 3p3 is what? 6. 3 number of objects. Understand? 3 number of objects taken 3 at a time. So 3p3 is equal to 6. Notation for permutation. This is very important to note. That is very important to note. N number of objects we have to arrange R at a time is denoted by NPR. NPR where R must be greater than or equal to 0, less than or equal to N. Notation for permutation is NPR. N number of objects we are arranging. N number of objects taken R at a time. 3 number of objects taken 2 at a time, that is nothing but 3p2. 3 number of objects taken 3 at a time, that is nothing but 3p3. These are the notation to denote what? Permutation. These are the notation to denote permutation. After knowing the notation, write the formula. Very important formula. So, formula, n number of objects taken R at a time, n number of objects taken R at a time is given by n factorial divided by n minus R factorial. So, very important formula where n objects are distinct objects. Means they are not same. A, B, C are distinct objects. They are not the same. NPR, very important formula. Okay, later if you want, later we derive this formula also. NPR is nothing but n factorial. Just last class we solved these type of problems. Yes, not same. NPR, here n number of objects we have to arrange R at a time. N objects, these objects are distinct objects. They are not similar. NPR is given by n factorial. We discussed in the last class. Yes, n factorial divided by n minus R factorial. See, observe here, 3p2 is what here? 6. Okay, we substitute here. So here we got 6, 3p2. We will see 3 factorial divided by 3 minus 2 factorial. So what? 3 factorial divided by 1 factorial. 3 factorial is what? 3 into 2 into 1 divided by 1. So answer is 6. Observe here. Answer is 6. Again, if you want this one also we solve. So 3p3. 3p3. 3p3 is how much? 6. Again, okay. 3 factorial divided by 3 minus 3 factorial. 3 factorial divided by 0 factorial. The last class I say we define 0 factorial is 1. So 3 factorial. So total answer is 6. So n number of distinct objects. This is a formula. Very important formula for permutation. Very important formula for permutation. NPR, and one more very important, N are distinct objects. They are not similar. And R must be, very important condition, R must be written here, greater than or equal to 0, less than or equal to n. R must be greater than or equal to 0, less than or equal to n. NPR is given by n factorial divided by n minus r factorial. NPR is given by, very important formula, n indicates distinct objects. Similar object we will see later. Okay, similar objects we will see later. Where n are distinct objects, we have to arrange n number of distinct objects, arrange r at a time is given by n factorial divided by what? N minus r factorial. So here we arrange 3 objects taken 2 at a time. 3 objects taken 2 at a time. 3p2 is what? 6, and 3p3 is what? 6. So we substitute in the formula also, we got the same result. Okay, for notation, n number of objects taken r at a time is generated by what? NPR. And very important condition, r must be greater than or equal to 0, less than or equal to n. This is the only one formula in the permutation. If anybody asks NPR, n number of distinct objects, taken r at a time is given by NPR is equal to what? Just last class we discussed such type of problems. Okay, and in the last class we see these are all the problems, but this is not a problem. This is a formula. N factorial divided by what? N minus r factorial. N indicates distinct objects, and r must be greater than or equal to 0, less than or equal to n. This is what? The permutation. After knowing the formula, we discuss some more notes, very important notes, one by one. Note number 1, or else first we write formula. Notation is n number of distinct objects taken r at a time is given by n factorial divided by n minus r factorial. Correct? NPR, n indicates distinct objects. R must be what? Greater than or equal to 0, less than or equal to n. One by one note we will discuss. Very important note. First one, r is equal to 0. What will happen? What will the result if r is 0? NP 0. Okay na? NP 0. N factorial divided by n minus 0 factorial. N factorial divided by n factorial get cancelled. NP0 is always equal to 1. Remember this one. This is also a formula. If r is 0, n may be any value. N may be, for example, 100 P0. It is 1. 1000 P0. No need to substitute in the formula. Directly we write the answer is 1. NP0, this is very important concept. NP0 is always equal to, if r is 0, is always equal to what? Always equal to 1. NP0. N may be any value, n distinct value, 1000 P0, 10,000 P0. 50p0, whatever it may be, if r is 0, remember this is very important, r is 0, it is always equal to 1. One node, first node. np0 is what? 1. We will see. If second node, r is equal to n. Okay, means I just now read here 3 objects taken 3 at a time. What I read on 3p3, correct now? 3 objects, both are same, r is equal to n. We will see in the formula what it gives the result. n factorial, I substitute here, n minus n factorial, n factorial, 0 factorial. So last class I defined 0 factorial is, we define 0 factorial is what? It is 1. So npn, it is nothing but what? N factorial. If r and n are equal, that is nothing but n factorial. For example, if I want 5p5, no need to substitute here. If you know this result, no need to substitute here. Directly we write it is nothing but what? 5 factorial. What is the value of 5 factorial? 5 factorial is 5 into 4 into 3 into 2 into 1. So we substitute here 5, 20, 20, 60, 120. Correct? So you know how to calculate. In the last class I explained everything. So 5p5. If I want what? 10p10. No need to substitute here. No need to substitute. If you know these two results, no need to substitute here. Directly we write it is nothing but what? 10 factorial. It is nothing but what? 10 factorial. Suppose if I want 100p100. 100p100. No need to substitute here. Directly we write it is nothing but what? 100 factorial. If r is 0, it is 1. If r is equal to n, it is nothing but n factorial. These two nodes are very important nodes. If np0, directly it is equal to 1. If npn, it is equal to what? N factorial. npn, it is equal to what? N factorial. One more note. R is 0, R is n over. Third note, R is equal to 1. R is equal to 1. What will happen? So we will see this one. N P1. N factorial divided by n minus 1 factorial. Correct? N factorial divided by what? N minus 1 factorial. So just last class I explained here. N factorial we can written as n into n minus 1 factorial. So denominator n minus 1 factorial. N minus 1 factorial, n minus 1 factorial. Observe here, this is also very important result. It is equal to n. It is not n factorial. It is equal to just n. If r is equal to 1, r is 0, it is 1. R is n, it is n factorial. Okay, one by one you have to see that result. R is 0, I written here. np0, it is 1. So np0, one by one result I written here. First result what we got? First result, if r is 0, np0 it is 1. Correct? np0 it is 1. Second result, npn, it is nothing but what? N factorial. npn, it is nothing but what? N factorial. Correct? Third result, if r is 1, np1, just know it is n, np1. Suppose for example, if I want to calculate 10p1, no need to substitute here. So directly, if you know this result, directly we write it is answer is 10. Directly we write answer is, suppose I want 1000 p1, so thus the answer is 1000. 100 P1, 50 P1, answer is 50. So overall result NP1, NP1, it is N. NP1, it is N. So one more result. Suppose R is 1 over, one more note, fourth one, R is 1 over, R is 2, R 0 over, R 1 over. If I take R is 2, then NP2, N factorial, first let's substitute here. So this is the formula. N factorial divided by N minus 2 factorial. So N factorial, that I can write as N into N minus 1 into N minus 2 factorial divided by N minus 2 factorial. N minus 2 factorial, N minus 2 factorial get cancelled. NP2, what? N into N minus 1. Very simple result. If R is 1, it is N. Fourth result. NP2, that is nothing but N into N minus 1. No need to substitute here. Suppose if I want 5P2, no need to substitute here. 5 into 5 minus 1. 5 into 4. Answer is 20. If you know this result, if you don't know, we substitute here. If you know this result, directly we write 5 into 5 minus 1, NP2, N into N minus 1. So 5, suppose I want 10P2, 10 into 10 minus 1, 10 into 9, answer is 90. Answer is 90. These are the results, some results. Okay, so one more result. If R is 2 over, suppose I want R is equal to 3. We will see this one more result. R is equal to 3. NP3. First let's substitute here. N factorial divided by N minus 3 factorial. N into N minus 1 into N minus, this is no, just in the last class I explained all this concept. Divided by N minus 3 factorial, N minus 3 factorial, N minus 3 factorial get cancelled. NP3. NP3 is nothing but N into N minus 1 into N minus 2. NP3, fifth, fourth over fifth result, NP3. NP3 is nothing but N into N minus 1 into N minus 2. N into N minus 1 into N minus 2. Observe this result. 3, it is 2. 2, it is 1. One number less. 1, it is 0. Sixth, I write result. NP4. If I want NP4, N into N minus 1, N minus 2, N minus 3. One number less. Correct now? One number. Suppose I want one more seventh result. NP5. NP5 is what? N into N minus 1, N minus 2, N minus 3, N minus 4. Like that. These are the results. Okay, these are the results. If you remember these results, it is well and good. If you don't know, simply only one formula. Substitute and simplify it. NPR, that is nothing but N factorial divided by N minus R factor. These are all the concept of permutation. Once again I explain. Permutation. If anybody asks what is permutation? Permutation means arrangement of an element in a definite order. Definite order means what? Taken some at a time or all at a time. In that arrangement, we divide into two parts. Distinct objects, similar objects. Firstly, for distinct objects. For distinct objects, NPR. NPR is nothing but N factorial divided by N minus R factorial. NPR is nothing but what? N factorial divided by N minus R factorial. We will see the problems. exercise exercise 7.3. First problem. How many 3-digit numbers can be formed using the digits 1 to 9 if no digit is repeated. If no digit is repeated. So this problem we can solve by using fundamental principle also. So we have how many digits? 1 to 9 means 9 digits. Arrangement 3 at a time. See, I use first fundamental principle of counting. For in the first class, what we discussed, we have to arrange 3 at a time. In the unit place, I can fill in how many ways? 9 ways. In the 10th place, so repetition of the digit is not allowed. We can fill in how many ways? 8 ways. In the 100th place, we can fill in how many ways? 7 ways. So these are all the events. This is E1 and this is E2. This is E3. All E2 is depend upon E1. E3 is depend upon E2 and E1. All these three events are not independent. They are dependent. So fundamental principle of counting. Total number. 7 into 8 into 9. Calculate. Five not 4. Total number of ways is 504. This is what? Fundamental principle of counting. Fundamental principle. Okay. So we will see this one. What will give the result by using permutation. What he has given? How many 3-digit numbers? We have to arrange 3-digit numbers can be formed using the digits 1 to 9. Using the digit 1 to 9. Solution. The total digits are 2 9. That is n is equal to so we have to form 3-digit that is r is equal to 3 without repetition. Without repetition. See, the total digits are 1 to 9. That is n is equal to 9. We have to arrange 3 at a time. That is r is equal to 3. One more very important, without repetition. So, the total number of arrangements is given by the total number of arrangements. The total number of arrangement is given by, so n is equal to 9p3, correct? The total number of arrangements according to the permutation, n is equal to 9, r is equal to 3. The total number of arrangements is given by 9p3. Okay, then you know the formula right here. Since NPR is equal to what? N factorial divided by n minus r factorial, correct? NPR is what? N factorial divided by n minus r factorial. So 9p3, 9 factorial divided by 9 minus 3 factorial. So just I only know the formula. How to solve this one? Simply 9 factorial divided by 6 factorial. 9 into 8 into 7 into 6 factorial. 6 factorial, 6 factorial, 6 factorial get cancelled. So the answer is total number of arrangements. Total, both are results, see, observe result. Total number of arrangements. See, this is the method to solve the problem. Total number of arrangement is what? 504. Total number of arrangement is what? 504. If they ask in the examination, which method we have to use, sir? That is choice to you. If you use fundamental principle of counting, no problem. Or else if you use permutation, that also no problem. If they mention by using permutation, find out the total number of object, means you have to use this method only. If they mention by using fundamental principle, find out the total number of arrangement, means we follow this method. If simply they ask the problem, choice is yours. Use the fundamental principles of counting or else use the arrangement. Okay, this is the first problem. See this problem carefully. Next problem. Second, in the exercise 7.3, second problem. How many 4-digit numbers? How many 4-digit numbers are there? With no digit repeated. No digit repeated. How many 4-digit numbers are there with no digit repeated? Okay. So n is what? See, observe here. First I use fundamental principle of counting. First I use fundamental principle of counting. Digits are 0 to 9. 10 digits in our pockets. 10 digits. Digits are 0 to 9. In our pockets, 10 digits. We have to take 4 at a time. This is very important. This concept is very important. Why I use this one? 4-digit number. If I write 1, 2, 3, 0, this is 4-digit number? No, it is what? 3-digit number. Sorry. If I write 0, 1, 2, 3, sorry. If I write 0, 1, 2, 3. This is what? Is it 4-digit number? No. It is what? 3-digit number. It is what? 3-digit number. So, unit place, 10th place, 100th place, 1000th place. Unit place, 10th place, 100th place and 1000th place. So, in the 1000th place, very important, 0 is not come. If 0 is come, it is not a 4-digit number. It is a 3-digit number. So, this can be filled in how many ways? 9 ways. 1 to 9 only. That means 9 ways. This can be filled in how many ways? 9 ways. Because in the 1000th place, if 0 comes, 1000th place, if 0 comes, it is not 4-digit number. He asked 4-digit number. He asked 4-digit number. In the 1000th place, 0 never comes. Correct? If 0 comes, it is 3-digit number. That's why we filled in the 1000th place 1 to 9. We use here 0. So 100th place we can fill in 9 ways. Because I use 9 and repetition is not allowed. 10th place we can use in 8 ways. Unit place we can use in 7th place. So 9 into 9 into 8 into 7. According to fundamental principle of counting. According to fundamental principle of counting. So total number of ways. Total number of ways is how much? 9. $4,536. Total number of ways is total number of 4-digit number 4,536. 4,536. Okay. How many 4-digit numbers are there with no digit is repeated? Okay. So we write the answer. Total digits are 0 to 9. N is equal to 10. We have to form 4-digit number. Correct? We have to form 4-digit number. That is R is equal to 4. Without repetitions. That is very important. Without repetitions. Then the total number of arrangements. The total number of arrangements. So, total number of, I write one more box here. So, this only 9P1, 9 objects we have to fill in one at a time. 1, 2, 3, 9P3. Correct? So, 4 boxes are there. 1000 place 0 never comes. 0 never comes means we use either 1, 2, 3, 4, 5, 6, 7, 8, 9 for only one box. So this can be done in 9P1. Remaining 3 box, 0 is here. So n is equal to, again n is equal to 9, because here we left out 0, we add 0 here. So into how many boxes are there? So 9P3, 9P1 into 9P3. So we calculate this one. 9P1 into 9P3. So that is equal to 9P1 is what? 9. 9 factorial divided by 9 minus 3 factorial. 9 into 9 factorial divided by 9 minus 3 is what? 6 factorial. So that is equal to 9 into 9 into 8 into 7 into 6 factorial divided by 6 factorial. 6 factorial, 6 factorial get cancelled. 9 into 9 into 8 into 7. So answer is what? 4536. You also calculate. So answer is 4009 into 9 into 8 into 7. 4536. This is what the second problem. See this problem very carefully. Observe this problem. So in the thousand place, very important, if 0 comes in the thousand place, if 0 comes, it is not a 4-digit number, it is a 3-digit number. We have to avoid 0 in the thousand place. We have to avoid the 0 in the thousand place. For that we use 1 to 9. This can be done in 9p. Only one box. This can be done in 9p1. Remaining 3 box, I insert 0. So again total number of digit is 9. So taken 3 at a time, 9p3. Use fundamental principle of counting or else use permutation. Understand? See this problem very carefully. Next problem. Third problem in the exercise 7.3, how many three-digit even numbers, how many 3-digit even numbers can be made using the digits (1, 2, 3, 4, 6, 7). If no digit is repeated, if no digit is repeated. So we solve this same type of problem in fundamental principle of counting. Okay, thus so directly I solve by using permutation concept. Okay, so here 3-digit even number, I use permutation concept. 3-digit even number already explained. If you want even number means unit place must be even number only. So you want 2, 3, 4, 6, 7. 1, 2, 3, 4, 6, 7. So n is equal to what? 6 even digits. Even digits are 2, 4, 6. N is equal to 3. Unit place, 10th place, 100th place. 3-digit even number. So this box must be what? Even numbers only. So this can be done by using permutation concept. Okay, by using permutation concept, this can be done. N is equal to 3. N is equal to 3. Taken only one box, one at a time. Correct? N is equal to 3. Taken one at a time. So this can be done by 3p1. Remaining two box. Repetition is not allowed. Repetition of the digit is not allowed. One number is over. So if I insert 2, so 2 is over. 1, 3, 4, 6, 7. So in these two boxes, N is equal to what? 5. Because one number is already here, because repetition of the digit is not allowed. Repetition of the digit is not allowed. N is equal to 5. Total number of boxes is what? R is equal to 2. So this can be done. These two boxes can be done. 5p2. Correct? 5p2. I use only the permutation because in the same problem we explain the fundamental principle of counting also. So total number of arrangements. Total number of arrangements 5p2 into 3p1. Total number of arrangements 5p2 into 3p1. Correct? So if you solve this one, so we got the answer. This is what the concept. So we write the answer. If you know perfectly, we write the answer. Firstly, total digits are 1, 2, 3, 4, 6, 7. N is equal to 6. Even digits are 2, 4, 6. N is equal to 3. We have to form 3-digit even number. Correct? We have to form what? 3-digit even numbers without repetitions. We have to form 3-digit even numbers without repetitions. Next, I write here the total number of arrangements. The total number of arrangements is equal to what? 5p2 into 3p1. 5p2 into 3p1. Total number of arrangements is equal to 5p2. 5p2 is what? 5 factorial divided by 5 minus 2 factorial. 3p1 is 3. 5 factorial divided by 3 factorial into 3. If you know already r is 2, r is 1. So directly we substitute, no problem. 5 into 4 into 3 factorial divided by 3 factorial into 3. 3 get cancelled. 5 into 4 into 3. 20 into 3 is how much? 60. So total number of 3-digit even number is what? 60. Total number of 3-digit number is what? 60. This is the method to solve such type of problems. Okay. So up to that we stop. We continue the remaining problems in the next class. Thank you.